Okay, hello guys. So we're gonna continue with our uh, work on series. We're gonna do today. We're gonna finish integral test, and then we're gonna do comparison test. Okay. So to remember, uh, let's recall what was the integral test. Let's do a new example for integral test. Uh, and so to review what we were doing. So let me share my screen. So last time we talked about the integral test. So what we did here. So last time we were applying the integral test. So what the integral test is saying is that if you want to check that as the sum is converging or diverging, you can check the related integral or that sum where an equals f of n, okay? But f must be continuous, positive, and decreasing on 1 and infinity, okay? So continuous and positive are easy. Decreasing is usually, that take a little bit. So let's make a new example of this. So let's call example. So determine whether the series sum n equals 1 to infinity ln of n divided by n converges or diverges. Okay, so this is ln of n, right? So like this. So before doing anything else, so we need to check that the function associated to this series is continuous, positive, the most important thing, decreasing. So an equals ln of n, that is our f of n. So ln of n over n, that is our f of n, okay? So I ask you guys, what is f of x?
ln x over x.
Correct, ln of x over x. So let's see first, before doing all this, one way to figure out fast is you can apply the test or not, is that the series must be a decreasing function. So first thing you can do is just graph it. So let's graph it. What is the name of this? Graph it. Okay, let's use Fortran because I forgot the one that I use. So plot ln of x divided by x. So I think it's this one, you see? So the function is increasing until 2, something like that. But then it starts going decreasing. Okay? So it's okay to be increasing for a little bit. Okay? Until 2, for example, or something like that. Until 2.1, 2.2, something like that, right? And then it start going totally decreasing the function. Okay? So that's what we want. The function has to be decreasing always after a certain point. So it doesn't have to be exactly at 1, because you see at 1, between 1 and 2, the function is increasing. But a little bit after 2, the functions start going decreasing. So that's not really a problem, because for 1 point, the function is not going to be divergent or convergent. Okay? So it looks decreasing. We will show that it's decreasing. We need to show it by hand. But what I need to do is to see if I can find the integral of this. If I cannot find of this, well, it's not too much that I can do, right? So let's find the integral of this. So the integral between 1 and infinity of ln of x divided by x dx. So go ahead, guys. So I give you 3 minutes to find this integral. Thank you. Sorry. How long have I been mute? So did you guys saw the graph? Well, was I mute when I was showing the graph?
Um, During the graph, I was able to hear you.
Okay. Okay. Thank you. So okay, you didn't miss that much. So since it's decreasing, at least graphically, right? We are going to show that it's really decreasing, okay, with the derivative. But what we really need to know is to be able to find this integral. So let me give you 3 minutes to find this integral, okay? So go ahead. You had 3 minutes to find this integral. Okay, so let's do it. So what technique should I use to find this integral?
Use substitution.
Substitution. Okay, so what would be the substitution?
ln x would be u.
So let me write it here, ln of x. Oh, x dx. Sorry, I put it's supposed to be a here. So u should be what? U should be
ln x.
ln of x. Then the u is 1 over x dx, correct? And then when I plug in here, limit of a goes to infinity, I get integral. And now I change these numbers to something else, CD. And then instead of ln of x, I write u. And 1x dx is du, right? So I get limit of a goes to infinity. And what is the antiderivative of u?
1/2 u squared.
Thank you. U squared divided by 2. And then evaluate between C and D. And then I go back, and instead of u, I put ln of x. So I get limit of a goes to infinity, ln of x squared divided by 2. And then I go 1 and a. And then I plug in my a and subtract -1. I get limit a goes to infinity of ln of a squared divided by 2 minus ln of 1 squared divided by 2. So ln of 1 is, what is ln of 1?
Zero.
Ln of 1 is 0, correct. And then what is the limit when a goes to infinity of ln of a? So this is 0. So what is this limit? Limit of a goes to infinity of ln of a squared divided by 2. What is that limit? Where is this function going? So you don't know, you just graph it, okay? So graph ln of x squared divided by 2. So please graph it and tell me where is this function going? When a goes to infinity. Oh, you can just put a. Ln of a squared divided by 2. Oh, decimals, right? It's called decimals. So you can graph it. Let me use decimals. So y equals, I think it's okay if I could put ln of a, I think. Ln of a, and this is square, and then divided by 2. So what do you guys say? Where is this function going? When a goes to infinity, the function goes to? Where is it going?
Infinity.
Infinity. It's increasing, right? So it's increasing, 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 going to infinity. Sometimes you think that when you see the curve from the pandemic, you think that goes to infinity, right? Hopefully not, but but this one is gonna go to infinity. So graphing is not enough, okay? Graphing is not enough, but we know that ln is increasing. So since it's increasing, the limit of ln of x is gonna be go to infinity. Okay, but you know, graphing is probably okay. You make me a graph, it's gonna be okay. So this limit is infinity. You know how ln of x. is, right? So this is going to infinity. So what do you say? This series is divergent or convergent?
Divergent.
Divergent. So this series is divergent. Okay. Why? Because I use the integral test and it's telling me that the integral is divergent. But before that, remember we had to check the 3 points, the critical points. So now we have to check, now that it works, so we need to check first. ln of x divided by x is continuous on 1 to infinity. Okay, so that one is continuous. We graph it, so we saw that it's continuous from 1 to infinity. 2 ln of x over x is positive from 1 to infinity. We graph it. You saw it, right? Everybody saw that it's positive from 1 to infinity. And number 3, that one didn't look totally increasing. Did I erase it? No. But it was something like this, right? So when I graph it, it was going something like, that, and then start decreasing. So it start decreasing like after 2, right? So it is decreasing from we can say 3 infinity, for example. Okay, so it's okay because you are using we can prove it. So but let's prove it. So f of x is ln of x divided by x. So this is what I mean, that you can do better than your calculator. You don't even know what your function is decreasing. This is going to show you exactly where your function is decreasing. Okay. So when I find, how can I see that the function is decreasing? How did we do it last time? How did we find the function is decreasing?
With the derivatives.
Right. So we need to find the first derivative. So the first derivative of this is going to be f prime of x. What is the first derivative? Everybody find me this derivative. Let me give you 2 minutes to find this derivative and show me that it's really decreasing. Okay. Okay, so the derivative of this could be, we can do it by the derivative of a quotient. So will be the x squared, then the derivative of the top is 1 over x times the bottom without derivative minus ln of x times the derivative of the bottom, that is 1. right? So we got ln of x. This x cancel with this x. So we got something like f prime of x equals 1 minus ln of x over x squared. So we need to figure out when this is positive and this is negative. So here you see basically we need to figure out when ln of x is bigger than 1. Then it will be negative. So we want to know when 1 minus ln of x is less than 0. Okay? That's what we need to know. Okay? Because if this guy is less than 0, then this is going to be decreasing. So we solve it. So 1 less than ln of x. We take exponential both sides. E to the 1 less than x. So this is going to be decreasing for x bigger than e to the 1. That is like 2.71, I think. Something like that. So e to the 1. So for this number, so basically for bigger than 3, the function is decreasing. So this sum, so you said, okay, but the theorem says that it starts at 1. Well, it doesn't really matter because you have the sum of n equals 1 to the infinity of ln of n over n could be ln of 1 plus ln of 2 divided by 2 plus the whole sum after 3. So, this is a real number, this is a real number, but this is divergent, so the whole thing is divergent. Okay? So that's how this, how this is a real life, real life, like a real good problem because you have to find the integral. You need to use some calculus to find your derivatives to see the function is decreasing. You need to graph it. You had derivatives at infinity. So this is a perfect example of a problem for the final. Okay? You can totally expect something like that for the final because in one question, I'm evaluating 3 or 4 things. Okay? So, and you have to show it. Okay? So that's good. Okay, so let's do the problem that we didn't finish last time. Last time we were just talking about P series, but we only check 2. We only check 1 over x squared or 1 over n squared. We check this one. And we check this one. Okay, so but we need to do the general case. So we're going to do the general case. So and this is going to be my last example of integral test. But we're going to start doing a lot of problems soon, and I'm going to let you time to do this because I do this if I do these problems by myself, I just since I already solved these problems, I'll solve these problems each problem in 1 minute. But that's not pedagogical. So I need to give you time to try to see what do you do. So you had several possibilities to check that a series is convergent or divergent. So I'm gonna teach you more next. But I'm gonna start giving you time to see how are you thinking, how are you applying these theorems, because I had to fix you some of those. Okay, that's the logic of that. Is kind of oriented. Okay, so let's do the general case. So example. for what values of P is the series sum 1 over n to the P n equals 1 to infinity convergent? Okay, so what we're gonna do, let's see, somebody text me. Okay, I'm just checking the chat just in case somebody's. Okay, so we're gonna do, so we need to check this 1 over np. So a sub n is 1 over np. So this is f sub n, right? So what is f of x? What is f sub x? F of x.
1 over xp.
1 over xp, thank you. So before doing anything, let's start checking the integral because, you know, if I cannot find the integral, so why do I waste time? So let's find the integral between 1 and infinity of 1 over x p dx. Okay. So let me give you 2 minutes. So let me write this. Limit of a goes to infinity, integral 1 to a, 1 over xp dx. Okay, so let me give you 3 minutes to try to find this integral. Okay, so what do? We go, how do we do this integral? What is the derivative of 1 over xp? What should I do? So you erase this one and then put x to the minus p, right? And what is the derivative of x to the minus p? You guys know. What is it? X. Yes? Somebody's gonna tell me?
Is it x to the minus p plus 1?
Correct. Divided by
Negative p plus 1.
negative p plus 1. Right? So then we evaluate between 1 to a. So we plug in a and subtract 1. So we get limit a goes to infinity, and then then you see a problem here. Because, so do you guys see any problem? Do you guys see a problem with P?
Is it negative?
Yeah, P could be negative, right? P could be less than 0. P could be positive, right? So, but let's keep going. So, because they are not telling us anything if P is positive or negative or anything. It's our job to decide what is a good P. So, I plug in my A. And then subtract, I plug in 1. So there'll be 1 and 1. But you see, I'll get minus P plus 1. Okay. So do you guys see another problem? With P. You should see a problem with P. Another problem with P. P cannot be what? P can be 1 or not?
It has to be greater than 1.
Yeah, P has to be greater than 1 to do this, right? So here, let's assume P bigger than 1. Because if P is 1, minus 1 plus 1 is division by 0. So I need P bigger than 1 to do this integral over here, this way, okay? So let's assume P is bigger than 1. So this will be fine. And when A goes to infinity, I'll get limit of A goes to infinity. P is bigger than 1. So minus P plus 1 is positive or negative?
Positive.
No, because P is bigger than 1. So minus P plus 1 is negative. Since it's negative, that one can go in the bottom. So it will be 1 over A, and then it will be P minus 1 times 1 over minus P plus 1. Minus 1 minus P plus 1. So this guy, when A goes to infinity, where this guy is going? Is 1 over something that is going to infinity, right? So this guy is in A is to a power P minus 1. P minus 1 will be positive. You move this guy to the other side, P minus 1 is positive. So this is a 1 over A to a power positive. So when A goes to infinity, this guy goes to 0. It's 1 over something. Remember we said 1 over n goes to 0 when n goes to infinity. 1 over n squared goes to 0 when n goes to all of those. So similarly for any number over here. If A is any number, that will go to 0. So this guy goes to 0. So I have this guy. This limit will be, so this whole thing goes to 0. So this will be 1 over P minus 1. For P bigger than 1. So this integral converges. Oops, sorry. This integral converges. This integral converges when p is bigger than 1. So if p is bigger than 1, the sum 1 over np converges. Okay? Of course, that's, again, I'm doing the long process because it's my job. I need to show you where all this is coming from. But for your exercises, what you need to remember is that we wrote last time. P series is converging if P is bigger than 1 and diverges if P is less or equal than 1. Okay? So let's see what happens when P equals 1. If P equals 1, so this is, now you guys are, you guys grow. I cannot just giving you formulas. This is not the idea of calculus. The idea of calculus is the opposite. Any formula you learn, you need to know where is this formula coming from mathematically. You're not just a dictionary, you don't memorize stuff. This is not grammar. This is logic, okay? So we created this universe. The mathematics was created for the human being. So everything we say can be proved or disproved in mathematics. Well, almost anything. Only there is some things that we can say that are true or not. We cannot decide that. But anyway, that's for mathematicians. But this, if p equals 1, what happens to this one? So we do again the integral test. Because this function using integral test, we already did it, right? Using integral test, we saw this is divergent, remember? I did that last class. That is divergent by the integral test. Now, what happened for p less than 1? If p is less than 1, have sum n equals 1, infinity 1 over np. Well, I do the same process, right, of the integral test. So I will do, if I do p less than 1, so I'll get, well, let's say p between 0 and 1, okay? Because if p less than 0, this is going to be divergent. If p is less than 0, then I have something like, let me put it here. If p is less than 0, the sum of n equals 1 to infinity 1 over np is really something like sum of n to the minus p. So minus p will be positive because p is less than 0. So this sum is going to be divergent. So this is going to be divergent. So less than 0 is easy. P less than 0 is easy. Between p0 and 1, so I do again my integral. Integral 1 infinity 1 over xp dx. And then I do again my trick. X to the minus p dx. And then I do my trick again. So I integrate x minus p plus 1 minus p plus 1. But p is less than 1. Therefore, this guy is what? Positive or negative? If p is less than 1, this guy is positive or negative?
Negative.
No,
What, 0?
because p is less than 1, so minus p could be like, for example, 1/2. So minus 1/2 plus 1 is 1/2, so it's positive. So when x goes to infinity, when I take my limit, right? When I integrate this function is gonna go to infinity, so this is gonna be divergent. Okay. Well, let's do the whole. Let's do the whole story slow. So let me do it here. You do all the steps. So limit a goes to infinity of integral between 1 and a x minus p dx, and then we integrate limit a goes to infinity x to the minus p plus 1 divided by minus p plus 1 between 1 and a, and then I plug in my a limit a goes to infinity a to the minus p plus 1 over minus p plus 1, then minus 1 over p minus 1. So it turns out that this guy minus p plus 1 is positive because I'm doing the case p is less than 1 and in between 0. So if p is between 0 and 1 is, for example, 1/3. Minus 1/3 plus 1 is 2/3. So it's a to the 2/3. So that will give me a to the 2/3. When a goes to infinity, that is going to give me infinity. So this integral will be infinity. So all this story to say, because this is probably the most important example we have, okay? And it's important in electrical engineering for this series. All this is the proof of this. The P series, 1 over n P is convergent if P is bigger than 1 and divergent if P is less or equal than 1. And last time I told you that, for example, the sum of 1 over n cubed is convergent, sum of 1 over n to the 4 is convergent, and sum of 1 over square root of n is divergent. And you just say because it's a P series, okay? Okay, guys, so we finished something really important today. That's really important. So now life is gonna be a lot easier for us since we have these important integrals. Okay, so the next thing I wanna do, this is a new topic, is the comparison test. So this is a new section from your let me open a new section. Let me call it here comparison test. So the comparison test, so it's gonna tell you if a function is convergent or divergent based on your knowledge. So since you know some series that are convergent or divergent, then you can compare them with something that you know, and then solve these new ones. Okay, so the comparison test says the following. Comparison, and this is important. I'm gonna give you this is gonna be part of the formulas. Comparison test. So the comparison test says, suppose that the sum of a sub n and the sum of B sub n are series with positive terms. This is really important. That means AN is positive, BN is positive. So this is for all n. Okay, so let me put this in red. If you have this series AN and BN, so we have the following. If the sum of Bn is convergent, and A sub n is less or equal than B sub n for all n, then the sum is also convergent. Okay, so that's part one of the integral test. And this makes sense. Remember, last time we gave a really good idea of how to graph a series, okay? So why this makes sense? Because, you know, you can imagine your series like this. So this is B1. It doesn't have to be decreasing or decreasing, nothing. Can't be anything. So this is B1, B2, B3, B4, B5, B6, so on, right? Because I'm saying this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, okay? So this is how high it is. This is my series. So A1 is lower. So A1 is this one, A2 is this one, A3 is this one, A4 is this one, A5. So for each rectangle, A1, A2, A3, A4, A5, A6, and so on. For each rectangle, B1 is bigger than A1, B2 is bigger than A2, B3 is bigger. So of course, if my sum of rectangles of B's is convergent, what does it mean convergent? It's less than 0. So if the sum of B sub n is less than infinity, of course, the sum of A sub n is less than infinity. So convergent means the sum is a real number. That's what it means. Convergent means you'll get that sum is going to be a real number, like geometric series. Okay? And the other part too says that if the sum of B sub n is divergent, well, let me put it like this, bro. If the sum of sum of B sub n is divergent, and in this case, it's the opposite. A sub n is bigger than B sub n. Well, in order to don't graph this, let me just change it, guys. So I don't have to do another graph. Yeah. See, if the sum of A sub n is divergent, and B sub n is bigger or equal than A sub n, then the sum of B sub n is divergent. So this is the opposite. If suppose that you know that the sum of A sub A1, AN, the sum of A1, A2, A3, A4 is divergent. Since B1 is bigger than A1, B2 is bigger than A2, B3 is bigger than A3, all those, of course, that sum has to be also divergent because it's even bigger than the A sub n. Okay, so that's why it makes sense. Okay, so let me give you. So you will see that it's not that easy to use that argument. So we need to do some practice. Example. So you tell me. So let me give you 2-3 minutes to find this one. The sum of n equals 1 to infinity of 1 over 2n plus 1. Is that convergent or divergent? And let me give you another one. Sum of n equals 1 to infinity 1 over 2n minus 1. So is divergent or convergent? Same thing. Is this sum divergent or convergent? Okay, so let me give you 5 minutes to try to do this too. So news is one you can solve, the other one you cannot with what we have right now. Okay, so go ahead. So one is convergent or divergent, the other one you cannot use the comparison test. Okay, so let me guide you a little bit. So you need to compare, let's say, A Let's say this is A. This is A and this is B. You need to compare A with another series. What could be a series that looked like something you had seen before? And it's a good series. It doesn't look familiar at all. I'm sure somebody knows. The solution. So I want to compare this 1 over 2n plus 1 with something. So what series do you know? Tell me the series you guys know. So you know geometric series, right? You know geometric series. That is something like the sum of a r n minus 1 n equals 1 to infinity. This is a really good one. What other series do you know? Huh? So you know sum of 1 over n squared. You know that one. Is that one convergent or divergent? What do you
I
say?
think it's divergent.
1 over n squared? No, that's convergent.
Ah.
Sum of 1 over n is divergent. You can say equals infinity. Okay. Let me ask you this one. Sum of 1 over 2 to the n equals 1 to infinity. Is that convergent or divergent?
Convergent.
And why? Correct. It's convergent. Why?
We proved it last week.
Yeah, because it's geometric. So this is geometric, and the radius is 1/2. Okay. So that's what we want to use. So that's pretty much what you have right now. You don't have that much. You could have a 1/2 to the n. You could have a sum of 1/3 to the n. You know those. It's a convergent. You could have also any power bigger than 1, like sum of n equals 1 to infinity of 1 over n cubed. That's less than infinity. N to the 4, something like that. A cube root of n, that's divergent. So those are the ones that you know. We haven't done that much. But you're gonna see that it's a lot. It's gonna be very useful what we have done. So this series, or this is AN or BN, whatever you want to call it. This is very similar to what? To which one of these? It's very similar to,
Is it 1/2 to the n power?
yes, to this one. So this is similar, so you put it next to it. You have to hold your brain like that. So they are similar. The question is, who is bigger?
Sir, I think it's 1/2 to the n power, not 2 to the n power.
It's the same thing because the n is 1 to the n divided by 2 to the n. That's exactly the same. That's kind of the 1 to the n is 1 over n divided by 2 to the n, and this is 1 over 2 to the n. Okay? So that's kind of part of the what is hidden in geometric series. So who is bigger? Let's say this is A, this is B. What do you guys say? Who is bigger, A or B?
B.
A.
So somebody said B, somebody said A. So let me teach you the trick. And you need to show it in the exam. So you just put it like here. So forget about the fraction, just put this one. So let me erase here. And this guy. This is gonna be 30% of your exam. You're gonna have to do this 30% of your exam, okay? What I'm gonna do next is very important. You need to pay attention. So fractions are ugly, but if I put it like this, 2 to the n plus 1 and 2 to the n, who is bigger, A or B?
A.
B.
A, because
A.
it has 2 to the n plus 1, and B only has 2 to the n. So this is 2 to the n plus 1 is bigger than 2 to the n only, right? This is telling me I have 2 to the n plus 1. Meanwhile, the right-hand side has only 2 to the n. But if I invert the fraction, so if I write this now, 1 over 2 to the n plus 1, then this will be inverted, the 1 over 2 to the n. You learned this in precalculus. 2 to the n plus 1 bigger than 2 to the n. If you invert this, then this is true. So this is true, therefore this is true. So the answer is, this is less than this guy. Okay, so you need to go on your college algebra or your precalculus and remember this. If A is bigger or equal than B, then 1 over A is less or equal than 1 over B. You guys remember that or not? You can test it. If you don't believe me, you can just take 3 bigger or equal than 2, yes. And then 1/3 is less or equal than 1/2, yes. So that's the good thing of these inequalities. If you don't remember, just plug in a number. Plug in 2 numbers, and then you will see what is true. Anyway, so from here, I got that this guy is less than this guy. So what do I know about this guy? The sum of that guy is convergent or divergent of B?
Convergent.
Convergent, because it's a geometric series. So now, since the sum of 1 over 2 to the n is convergent for being a geometric series, of radius r equals 1/2, and so this is 1 over 2n is bigger than 1 over 2n plus 1. By the comparison test, this sum, the sum of 1 over 2 to the n plus 1, so this is less than this sum, right? We know that. But this sum is less than infinity. Therefore, this one is convergent. So this sum is converging by the comparison test. So basically, I'm saying this guy, using the comparison test, I'm saying this guy is A sub n, this guy is B sub n, right? And I'm using the comparison test. If the sum of B sub n is convergent and this an is less or equal than bn for all n, then the sum of n is also convergent. So that's what I'm using, the comparison test. Okay? So how much time I have? We can do another one of comparison test. Let's do this one. It's also, this is kind of, it's gonna be, you have to reduce it to, this series reduces like a pre-calculus college algebra thing, inequalities. So, like calculus 1 stuff. So you need to kind of do a lot of this so you start remembering. So determine whether the series sum of n equals 1 to infinity 5 over 2n squared 2n squared plus 4n plus 3 is convergent, converges or diverges. Okay, so look at my list. So this is the series. What series looks something similar to what we have over there? We have, the one we have is 5, I'll put it here. 5 over 2n squared plus 4n plus 3. So which one of these series looks like somehow similar to that?
Is it 1 over n squared?
That's correct, this one. Okay, so you put it one next to each other, so at least they have something in common, right? So you put it here, 5, 2n squared plus 4n plus 3, and you put next to it 1 over n squared, okay? So you know this one is convergent, right? But maybe we can forget about the 5, okay? Because with 5 or not 5, the function will be convergent or divergent. So let's forget about this 5. That's a cost, that's not an n. So I can take that 5 out of the sum. So that looks similar, but maybe I can do better, right? Instead of 1 over n squared, in order to compare, I can do it better. How could I improve this in order to compare? What do you think? What could be better than 1 over n squared? So I can compare these two guys. Let me put these 2 over here. 2n squared. Because that's also gonna be convergent. If 1 over 2n squared is the same that 1/2 son of 1 over n squared. I can take the 2 out. So if this is convergent, this is convergent too. Okay? Because I can take the half out. So now let's compare these two guys. Who do you think is bigger? A or B?
B.
B. How can we prove that? We do as we did before. So let's forget about the fraction. Fractions are ugly. So 2n squared plus 4n plus 3. And let's put it here, 2n squared. Who is bigger? A or B?
A.
A. Because, you know, you have 2n squared and you have 2n squared. And you have 4n plus 3 all the time. Because n is always positive, right? So we are adding positive, positive, positive. This always bigger. When I go to fraction, when I invert, this happens. Okay. So this guy is always less than this guy. So this guy is gonna be convergent. So because this one is convergent, we can write it like this. Since the sum of 1 over n half n squared equals 1/2 sum of 1 over n squared is less than infinity for being a p series, with p equals 2, okay, and and 1 over 2n squared plus 4n plus 3 is less than 1 over 2n squared, then by comparison test, the comparison test, the sum 1 over 2n squared plus 4n plus 3 n equals 1 to infinity is also convergent. And also, when you multiply times 5 both sides, you also get the whole thing convergent. And also, multiplying times 5 both sides, you get sum n equals 1 to infinity 5 over 2n squared plus 4n plus 3 less than infinity. Okay, guys. So I'm gonna stop here. So this is comparison test. I'm gonna open the whiteboard for this, and they're gonna be very similar. Problems are very similar. You don't have too much to choose from. It's gonna be P series or geometric series to compare with. Okay. I'm gonna teach you another method tomorrow that is called comparison test. And tomorrow I'm gonna teach you 2 more tests.